Black holes are some of the most peculiar and captivating phenomena in the cosmos. Their extreme density results in an immense gravitational pull, so intense that even light cannot escape their grasp. While it's challenging to detect the vast majority of the more than 100 million black holes that may exist in the Milky Way, the supermassive black hole at the center of our galaxy, Sagittarius A, is estimated to be about 4 million times the mass of the Sun and located approximately 26,000 light-years from Earth, according to NASA. The first ever photograph of a black hole was taken in 2019 by the Event Horizon Telescope, EHT, collaboration. The awe-inspiring image captured the black hole at the center of the M87 galaxy, located 55 million light-years away from Earth, and caused excitement among scientists worldwide. Albert Einstein first predicted the existence of black holes in 1916 with his theory of general relativity. The term black hole was coined by American astronomer John Wheeler in 1967. For decades, black holes were known solely as theoretical objects. The initial discovery of a black hole took place within the Milky Way, in the constellation Cygnus, also known as the Swan. In 1964, celestial sources of X-rays were detected by a sounding rocket, marking the first indication of a black hole according to NASA. It was later determined in 1971 that these X-rays were emanating from a bright blue star orbiting around a peculiar dark object. It was hypothesized that the X-rays originated from the stripping of stellar matter from the bright star, consumed by the dark object, a black hole that devours everything in its path. According to the Space Telescope Science Institute, approximately 1 out of every 1,000 stars has enough mass to become a black hole. Given that the Milky Way is home to over 100 billion stars, there could be over 100 million black holes residing within our galaxy. Although identifying black holes is an arduous task, NASA estimates that there may be as many as 10 million to a billion stellar black holes within the Milky Way. The nearest black hole to Earth, dubbed the Unicorn, is located roughly 1,500 light-years away. This black hole candidate received its name from its residence in the Monoceros constellation, meaning the unicorn. Its incredibly low mass, approximately 3 times that of the Sun, makes it a unique and rare specimen. In 2019, the first ever image of a black hole was captured and released by the Event Horizon Telescope, EHT, collaboration. The EHT observed the black hole located at the center of galaxy M87 while examining the event horizon, which is the region beyond which nothing can escape from a black hole. The image showcases the abrupt loss of photons, particles of light, and provides astronomers with a new area of research into black holes, as they can now observe what a black hole looks like. More recently, in 2021, astronomers revealed a new perspective of the enormous black hole situated at the center of M87 by demonstrating how the colossal structure appears in polarized light. The new image displays the black hole with even greater detail, as polarized light waves differ in orientation and brightness from unpolarized light. This polarization is an indication of magnetic fields, and the image confirms that the black hole's ring is magnetized. Black holes have 3 layers: the outer and inner event horizon, and the singularity. The event horizon marks the boundary surrounding the mouth of the black hole, beyond which light is incapable of escaping. Once a particle enters the event horizon, it is unable to exit, as gravity remains constant across the event horizon. The inner region of a black hole, where the mass is located, is known as the singularity, which is the only point in spacetime where the black hole's mass is concentrated. Astronomers are unable to observe black holes directly like they can with stars and other celestial objects. Instead, they must rely on detecting the radiation that black holes emit when gas and dust are pulled into their dense gravitational field. However, supermassive black holes, which are typically found at the center of a galaxy, may be obscured by thick dust and gas that surrounds them, making it difficult to detect their emissions. Occasionally, matter being drawn towards a black hole may bounce off its event horizon and be propelled outward at high speeds, creating bright jets of material. Although the black hole itself remains invisible, these powerful jets can be observed from great distances. The 2019 image of the black hole in M87 captured by the EHT was an impressive feat that required 2 years of research and analysis even after the data was collected. This was due to the massive amount of data generated by the collaboration of telescopes spanning multiple observatories worldwide, which was too large to transfer over the Internet. Researchers anticipate that as time progresses, they will be able to capture images of additional black holes, creating a repository of what these enigmatic objects look like. The next target is expected to be Sagittarius A, the black hole at the center of the Milky Way galaxy. Sagittarius A is of particular interest as it is quieter than expected, possibly due to magnetic fields dampening its activity, as reported in a 2019 study. Another study conducted that year revealed that Sagittarius A is surrounded by a cool gas halo, providing unparalleled insight into the environment surrounding a black hole. Thus far, scientists have identified 3 categories of black holes: stellar, intermediate, and supermassive. When stars run out of fuel, they may collapse or fall into themselves, forming either a neutron star or a white dwarf if they are smaller, or a stellar black hole if they are larger. Stellar black holes are relatively small but incredibly dense, packing over 3 times the mass of the Sun into a city-sized diameter. They consume dust and gas from surrounding galaxies to grow in size. While small black holes are scattered throughout the universe, supermassive black holes dominate, with a mass millions or even billions of times that of the Sun but about the same size in diameter. These black holes are thought to be present in the center of every galaxy, including the Milky Way. However, scientists are unsure how these enormous black holes form. Some theories suggest that they may be the result of hundreds or thousands of small black holes merging, the collapse of large gas clouds or stellar clusters, or large clusters of dark matter. Dark matter cannot be directly observed, but we can observe its gravitational effects on other objects. Previously, scientists believed that black holes existed only in small and large sizes. However, recent research has shown that intermediate black holes, IMBHs, could potentially exist. These black holes could form when stars in a cluster collide, triggering a chain reaction. If several of these IMBHs form in the same region, they could eventually merge to create a supermassive black hole at the center of a galaxy. In 2014, astronomers discovered what seemed to be an intermediate mass black hole in the arm of a spiral galaxy. Recently, in 2021, astronomers used an ancient gamma-ray burst to detect another intermediate mass black hole. Despite the hints of their existence, IMBHs have been difficult to find. Astronomers have been looking very hard for these medium-sized black holes, said study co-author Tim Roberts from the University of Durham in the UK. In 2018, research suggested that IMBHs may be present in the heart of dwarf galaxies. Observations of 10 such galaxies, 5 of which were previously unknown, showed X-ray activity commonly seen in black holes. The black holes detected had masses ranging from 36,000 to 316,000 solar masses, and the data was collected using the Sloan Digital Sky Survey, which examines approximately 1 million galaxies and can identify the light signals commonly emitted by black holes that are attracting nearby debris. In 2015, gravitational waves resulting from the merger of 2 stellar black holes were detected by astronomers using the Laser Interferometer Gravitational Wave Observatory, LIGO. The discovery revealed the existence of larger-than-expected black holes with masses greater than 20 solar masses. The LIGO's observations also provided insights into the direction of black hole spin. When 2 black holes spiral around each other before merging, they can spin in the same or opposite directions. The observations of companion black holes with different spin orientations suggest that black holes in a stellar cluster may pair up and sink to the center of the cluster, rather than forming from 2 stars that were born together. "We're starting to gather real statistics on binary black hole systems," said LIGO scientist Keita Kawabe of Caltech, who is based at the LIGO Hanford Observatory. "That's interesting because some models of black hole binary formation are somewhat favored over the others even now, and in the future, we can further narrow this down."